Hi friends, welcome to my another video. Today in this video, I will discuss about the accuracy class of current transformer. This is one of the detail present in the current transformer nameplate. Here you can find that there is a class mentioned 0.5 and here also the class mentioned 5P20. In this video, we will try to understand what the class 0.5 is, what the class 5P20 is, and what is the significance of class mentioned in the current transformer nameplate. This is my one of the video in the current transformer series. I have already been discussed why we need current transformer, what is the working operation of current transformer, what is the CT ratio of current transformer, what is the burden of current transformer, and in this series now we will discuss what is the accuracy class of current transformer. So let's start this video. In order to understand the accuracy class of the current transformer, we have to understand first what are the different type of current transformer based on the application. There are two types of current transformer based on the application. First one is metering current transformer and second one is protection current transformer. As the name suggested, metering current transformer is used for metering and measuring of the power supply parameters like ampere, power factor, kilowatt hour. The protection current transformer is used to operate the relay in order to protect the circuit during fault condition. So the load for the protection type current transformer will be different types of relay like the earth leakage relay, earth fault relay, motor protection relay, overcurrent relay. So we can say that the metering current transformer has a load like ammeter, kWh meter, power factor meter, and the load for the protection type current transformer is different types of relays. From this discussion, we can say that the metering type current transformer should have a very precise accuracy because it's measuring the electrical parameters. But the protection type current transformer should not require to be that precise accuracy which metering type current transformer have. Because the purpose of the protection type current transformer is to handle that high level of fault current, and in that situation the protection current transformer should give signal to the relays to operate in order to break the circuit. So the purpose of protection transformer is not to measure the electrical parameter but to activate the relay in order to break the circuit during fault condition. So the accuracy for the protection class transformer should not be very precise. Now let us discuss the difference between the metering type current transformer and the protection type current transformer. The first difference in metering current transformer and the protection current transformer is that the operation over a limited range of current for the metering current transformer and operation over a wide range of current in the protection type current transformer. What does it mean? Let me explain this one. To better understand this topic, let us take an example. I took one CT and a conductor whose current need to be measured. Suppose here 100 ampere of current is flowing through the conductor and this CT has a CT ratio of 100 by 5. So what will happen when there is 100 ampere of current is flowing through this conductor? Then the secondary winding have the current of 5 ampere. Okay, and suppose due to some fault in the load there is now 200 ampere of current is flowing through this conductor, but the CT ratio is 100 by 5 only. So during the fault, when there is a 200 ampere of current is flowing through the conductor, then the flux produced by the 200 ampere of current will link to the secondary winding and it will try to produce the current more than 5 ampere. In that case, suppose 8 ampere is current is flowing due to the fault current in the primary winding. So the ammeter will damage because the ammeter which we connected with the secondary winding has the maximum ampere rating of 5 ampere. So the ammeter will damage. But this situation will not happen. Why? Because after a 120% of the rated current, that is in my example 120% of 100 is 120 ampere. So whenever the current more than 120% will flow through the conductor due to any fault, the core of the CT will get saturated. Here the saturation of the core means that any current after the 120 ampere in the primary conductor, the flux in the core will not change, and due to no changes in the flux in the core, there will be no more changes in the current of the secondary winding. As after the 120% of the rated current, the core gets saturated, so there will be no more changes in the secondary winding current. So the instrument which is connected with the secondary winding will be protected from the fault current, as there is a no changes in the secondary current after 120% of the rated current in the primary winding. From this discussion, we can say that the core of the metering type current transformer should saturate after the rated current in order to protect the instrument connected with the secondary winding of the current transformer. Now let us take that CT is now not metering type, but it is a protection type current transformer. In this case, the CT ratio is same 100 by 5, and due to fault in the load, there is a 200 ampere of current is flowing through the CT. As this CT is a protection type CT, then there will be some relay connected with the secondary winding of this CT. Unlike the metering type current transformer, the core of the CT should not saturate for the protection type current transformer. Why? Suppose if the protection type current transformer core is saturated, then after the fault, whatever current is flowing through the conductor, the current in the secondary will be only 5 ampere, and this current will go to relay, and relay will think that this is a normal condition. So in order to have a more current in the secondary winding, the core of the protection type relay should not saturate, so the flux linkage will happen after the rated current, and the secondary current will change accordingly to the primary current. Suppose in the fault time there is a 200 ampere of current is flowing through the CT, then as the core not gets saturated, then there will be a 10 ampere of current is flowing through the secondary winding of the current transformer. But for this relay, only the 5 ampere current is a normal condition. So as this relay will get 10 ampere of current, this relay will give command to break the circuit in order to protect the load from the fault. So what we studied so far, that for the metering type current transformer, the CT core should saturate in order to protect the instrument like ammeter, kWh meter or power factor meter to protect. But for the protection type current transformer, the core of the CT should not be saturated in order to have the high current in the secondary winding. So the relay will understand this is the unhealthy condition and it will trip the circuit. Hope you understand the first difference, that is the operation over a limited range of current and operation over a wide range of current. Why it is written? Because the operation of the metering type current transformer is only till 120% of the rated current, which is very limited, just 20% more than the rated current. But for the protection type current transformer, the CT should operate 10 to 20 times more than 10 to 20 times more than the rated current. So the range of the operation for the protection type current transformer is very wide, that is 10 to 20 times of the rated current. The second difference between the metering current transformer and the protection current transformer is these required good accuracy up to approximately 120% rated current, and the accuracy is not important in the protection class. As I told you in my previous discussion that till 120% the precise accuracy is required for the metering current type transformer, and the accuracy for the protection type transformer is not that precise required. Okay. The third thing is required low saturation level for the protection instrument. Yes, I discussed already this one. And the required high saturation level to break the circuit during fault. This already I discussed. The core of the current transformer is made up of metering type current transformer made up of nickel iron alloy, and the core of the protection type current transformer made up of grain oriented silicon steel. So it will have the high saturation, and due to the nickel iron made alloy core, the saturation will be very low. The other difference between the metering type current transformer and protection type current transformer is that for the metering type current transformer, the accuracy is expressed as 0.1, 0.2, 0.5, 1, 3 and 5. And for the protection type current transformer, the accuracy is expressed as 5p20, 10p20, 5p10, so on. Let me explain you what is what does this number represent in the metering class as well as in the protection class current transformer. Here the accuracy class of the metering type CT is given as 0.5. What does it indicate? Let me explain you. Here the CT ratio is 50/5 for this CT. So this 0.5 indicate that when this CT is measuring 50 ampere of current, then there will be error of 0.5%. So what is the 0.5% of 50? That is 0.25 ampere. So when this CT is measuring 50 ampere of current, then it either give the current of 50 minus 0.25 ampere or 50 plus 0.25 ampere or any current in between this. So this indicate that the how much percent error can be given by a particular CT of its CT ratio. Hope you understand. Let us take another example to better understand this accuracy class of metering type current transformer. Suppose there is a CT of 100/5 CT ratio and the class is given as 0.1. It means that this particular CT will give error of 0.1% on its rated current. So what would be the 0.1% of 100 ampere? That is only 0.1 ampere. So this CT will reflect the reading of 100 minus 0.1, that is 99.9, and 100 plus 0.1, that is 100.1. So this CT will reflect the reading between 99.9 to 100.1 ampere. So hope you understand what is the accuracy class for the metering type current transformer. Let us study the accuracy class for the protection type current transformer. Here the accuracy is mentioned as 5P20. Let me explain this one, how to decode this number which is mentioned on the protection type current transformer. As I told you, the protection type current transformer should handle the multiple time of its rated current during fault condition. Here the 10 indicate that if the primary current is 10 times to the rated primary current of the CT, then the CT will be perfectly okay and it will give 5% error. Let me take an example of the CT. Here you see that the primary current rating of the CT is 2500 ampere and the accuracy class is written as 5P20. It means when there is a fault in the conductor, then this CT will be perfectly okay till the fault level of 2500 into 20, that is 50,000 ampere. When there is a current in the conductor of till 50,000 ampere of current, then this CT will be perfectly okay, but it will reflect an error of 5%. Let us take another example of the protection type current transformer in order to better understand the accuracy class of protection type current transformer. Here you see that the ratio is given as 200/5 ampere and the class is written as 10P10. What does it mean? It means that if the primary current is 10 times of its rated primary current, that is 200 ampere, the CT will be perfectly okay. It means that if there is a 2000 ampere of current is flowing through the primary winding, then this CT will be perfectly okay, but it will give an error of 10%. Hope you clearly understand what is the accuracy class of protection type current transformer and how to decode it. I hope you clearly understand what is different type of CT based on its operation, that is metering type CT and the protection type CT. What is accuracy class for the metering type CT and what is the accuracy class for the protection type CT, and what does this number indicates in the classes which is mentioned in the nameplate detail of current transformer. I hope you find my video informative. If you really like my video, then please give thumbs up and subscribe to my channel. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.